question paper here. This is a grade 12 maths paper 1. This is an exemplar for 2025. This was out of 150 marks for 3 hours. So I'll break this question paper into 12 parts because there are 12 questions. So there'll be 12 separate videos for each question, right? So this is because I believe I'll make each question, I'll break down each question so that you all understand what is required and how to solve these questions, right? So for this video we'll be looking at question 1. We'll be only looking at question 1, and then for the next video it will be question 2, and so on and so forth, right? So without further ado, let's get started. So first of all, we'll look at these instructions here. So instructions and information. Read the following instructions carefully before answering the questions. Okay, so these questions, or this question paper consists of 12 questions. Answer all the questions in the special booklet, answer booklet, then clearly show all calculations, diagram, graphs, etc. That you have used. Answer all, or rather answers only, will not necessarily be awarded full marks. Okay, so you may use an approved scientific calculator, non-programmable and non-graphical, unless stated otherwise. If necessary, round off, right? This one again, very important here. If necessary, you should round off your answers to 2 decimal places, unless if it's stated otherwise. Diagrams are not necessarily drawn to scale. Okay, and then an information sheet with formulae is included at the back of the question paper. And then finally, write neatly and legibly. Okay, so let's get started with question 1. So question 1 is solve for x. Okay, so question 1, question 1 is it has to be the most easiest part. I'm not saying it is easier, but it has to be the most easiest part because that's where like 3 marks are given. But here you should at least get about 24, right, out of 27. You should get about 24 out of 27 or more, all full marks. All full marks. So let's solve for x in this case, right? So question 1 point okay, so question 1.1, solve for x, right? It is given that x times x minus 3 is equal to 0. Okay, so let me do this instead. Okay, so here is the first question here, right? So x times x minus 3 is equal to 0. So we this one is for 2 marks. So but first of all, we know that every number or variable that is multiplied by a 0 will equate to 0. For instance, if I have a times 0, whatever value of a is, I will always receive, or I'll always have an answer equal to 0, right? I can have 0 times a, I'll still have 0. Can have 10 times 10 raised to the power 6 times 0, it will always equate to 0. So whatever value that I have, right, whatever value that I have multiplied by 0 will equate to 0, right, which is what we have here on the right hand side, right? So you notice that this part here is actually equated to 0. So what does that mean? It means that since here we are this is a product, we are multiplying, right? So it's either this part here, x is equal to 0, or x minus 3 is equal to 0, right? So we are not saying x equal to 0 and x minus 3 equal to 0, but we are saying x is equal to 0 or x minus 3 equal to 0, right? Well, we can have both of them equal to 0, because you know that 0 times 0 is equal to 0, but then we want either the two to be 0 actually, right, separately. Okay, so in this case we notice that x is equal to 0, and then here if we had to solve for x, then we will have, if we transpose the 3 on this side, then we have x equals to 3, right? As easy as that, right? That's your 2 marks there, right? So your first mark will come there, and then your other mark will come here, right? And then for 1.1.2, here they're saying solve for x correct to 2 decimal places, right? So here they're giving you a hint, right? This hint, it tells you that, well, I should use a quadratic equation, right? So you should actually use a quadratic equation, and we know that a quadratic equation is given as x is equal to b, minus b. Okay, so x is equal to negative b plus negative the square root of b squared minus 4ac. This is all divided by 2 times 8. Let me just remove this part here. Okay, so this is actually the formula to calculating your roots or your x value, right? And then you can just substitute. So, but first of all, your 1 mark will come from placing this equation into a standard form, right? Remember, a standard form is given as ax squared plus bx plus c equated to 0. So this is what we actually want to see, so that you get your mark. So actually have to place put this equation in standard form. So I'll have 2x squared minus, right? Okay, so 2x squared minus 4x and then plus 1 is equated to 0. So what I did is I transposed the 4x to the left hand side, right? And then I equated this this value here, or rather this equation, to 0, right? So now I have my standard equation. So we notice that my a here is 2, then this is a negative, so that means my b is a negative 1, and my c is a positive 1. And then what I do is I actually substitute, whereby I have my a equal to 2, my b equal to negative 4, and then my c will be 1, right? I hope you can see that color there. And then if I do that, let me quickly substitute this into my calculator. I have negative 4 plus the square root of negative 4 squared minus 4 times 2 times 1 divided by 2 times 2. So my first x value is 1.71. Remember, you're rounding off to 2 decimal places. Or my second x value will be, if I put a negative, I will get 0.29, right? So these are the two values that you should get when you substitute into your quadratic formula. Okay, I hope that makes sense. And yeah, let's move on to the other equations, the other questions. Let's move on to the other question. Okay, so question 1.3. Okay, so question 1.1.3 is given that we have x squared minus 2x minus 3, which should be greater than 0. So this is for 4 marks as well. Okay, so first of all, what you want is you to actually factorize this, right? So I have x and I also have x. Then the factors of 3 is 3 times 1. These are the only factors of 3, so it's 3 times 1. So here I have a negative and a positive. Okay, so how you actually do this is you first look at the number that is in the middle, right? Look at this number here, the b. So I can see that b is actually negative 2, right? And then after that, I'm going to write all my factors of 3 on the right. Then after that, what do I do is I look at if I should add or subtract these two numbers so that they will produce a negative 2. Just like 3 plus 1. 3 plus 1 will give me a 4, right? 3 minus 1 will give me a 2. And then minus 3 minus 1 will give me negative 2 or negative 4. My bad. Negative 4. And then negative 3 plus 1 will give me a negative 2, which is what I want right there. So that means I'll take this one here. So that means that my x will actually be, my first x will actually be, my first bracket will have a negative 3, and then my second bracket will have a positive 1, right? So that's actually how we factorize quadratic, or you can also use a quadratic equation if you are more confident with that or comfortable with that. You can also use that. So when I'm done with this, what I tend to do is I actually like to not basically having to draw the quadratic equation, but then we know if my x is a positive, then I know that I'll actually have a smiley face. Then if my x is a negative, then I have a sad face. So what I do on the side, I just draw a graph that looks like that, right? It doesn't matter how it is, but I know my graph will look like this. Why? Because I actually have two non-equal roots, right? So I have these two roots here that are not equal. What are the two roots? My two roots is x is equal to 3 and x is negative 1. So I have x equal to negative 1 and x equal to 3, right? So you actually don't have to draw this graph to scale or write these values. So all that we want is, okay, so first of all, if you notice this sign here, right, this sign says my equation is bigger, right? It's bigger than 0. So what is something bigger than 0? So something bigger than 0 is actually a positive. Okay, sorry about that. So something bigger than 0 is actually a positive. Okay, so if it's a positive, we need a positive y value. Remember this function here. This function here is given as fx, right? And what do we know about fx? Fx is actually y. So what I'm saying is that what are the values of x, right, that I'll put on my function and will produce a positive y value. Okay, so if I look at on this side of the graph, you can see that here I have my values of x that are negative, right? So starting from negative 1 going this way here, so I notice that my values of x here will actually give me a what? A positive y value. Why? Because they are above the x-axis and they're actually on this side here, right? Notice that this side of the Cartesian, or rather of the line, of the y line, is actually positive y. So these values of x on this side will produce a positive y value, right? And that's actually what we want. We want a positive y value, right? And if you look at this side as well, this side here going this way, whatever value I place of x, it will actually produce a positive y value. So my final answer will be x should actually be the numbers that are less than -1 should be less than -1. So now be mindful of this. You can see that here I didn't include the 0, but if I place a -1 here, I actually get a 0. So here I'm not going to include -1, so I'm just going to say, well, x should be less than -1, or x should be greater than 3, right? So x should be less than -1, or x should be greater than 3, all the x values that are greater than 3. And then here on this side here, you can see that here in the middle, you can see that these ones will produce a negative y value, which are values that are less than 0, which is what we don't want, right? So yeah, so the reason why I'm saying or is because there's actually a gap here, right? Let me use a different color. You can see that there's actually this gap here, these values of x that are actually left out there, right? So I cannot say x and 3. If I say x and 3, that means I'm including the values within or between -1 and 3. But if I say x less than 1 or x greater than 3, then I'm excluding those other numbers there, right? Okay, I hope that makes sense. Yeah, so my final answer will be this here, right? Or you can actually put this in bracket and be you can put this in scientific notation. Is it scientific notation? Oh yeah, but you can put this like this, or from 3 to positive infinity, right? So you can use either one of the two, right? It is actually totally up to you, right? They are both correct. Okay, wait, what happened there? Excuse me. Okay, let's move on to 1.1.4. Okay, so 1.1.4. So for 1.1.4, I have 2x minus 2x plus 2, and then minus 32, which is equal to 0. So if you have watched my prior videos, you will actually notice that this is okay, when we are dealing with exponents, right? This is an exponent. When we are dealing with exponents, what you want to do first is to actually change everything so that we have all the numbers placed in exponential form. Okay, so what I want to do is I want to change this 32 so that it will be the same as the base, so that I'll have the same basis throughout, right? So I'll have 2x minus 2x plus 2, and then minus, right, minus, this will be 2, and then if you can go to your calculator and then press 32, then press an equal to sign, and then press shift and look for a knob or a button, not a knob but a button that is written fact, right? And then press fact, and then you should get something like this. should get something like this here, right? Or you can just do this manually, but I wouldn't advise to do that manually as you do not have that much time. You can just use a calculator, right? That's why we have calculators. So yeah, but then with this one here, by looking at this, I can see that okay, here I actually have a quadratic equation, right? Let me show you. So I have 2x minus 2. I can break this into two parts, right? And then minus 2 raised to the power 5. Remember, when you're multiplying the same basis, you add the exponents. Okay, so here I can say, well, let k equal to 2x, right? So here I will have negative 2 squared times, remember our k is now 2x, and this is 2x, so I'll have I'll have k, and then minus 2 raised to the power 5, which is equal to 0. And then here, right, so here I have two of these, right? I have two of these, so that means that to get two of them, it's more like saying k times k. So I have the same basis. I'm adding the exponents, therefore I'll have k squared, right? So I'll have k squared on top. Okay, so actually here I didn't have to change. Okay, this is 2 raised to the power 2, that's 4. So I have 4k minus 32, right? I didn't have to change what do you call this? I didn't have to change the 32 into an exponential form. Okay, so now we have to factorize this. Well, you can use a quadratic equation, but in this case, let's write all the factors of 32, right? What are factors of 32? You have 8 times 4, right? You have 8 times 4. Well, you can see that 8 times 4, it will produce a negative 4 here, right? So meaning I can put an 8 and a 4 here. Since I have a negative, so I need a negative 8 plus a 4 so that I can get a negative 4. Alright, so negative 8 then plus here. So I notice that my k is equal to 8, or my k is negative 4, right? So if I resubstitute, I know that I'm not looking for k, but I want x, right? But I know that k is 2 raised to the power x, as stated here. We did define this there. So I have 2x equal to 8, or I have 2x equal to negative 4, right? And then if you solve this one here, I mean, you can solve this in multiple ways. But the most easiest method is to, well, change the 8 into an exponent form, and therefore your x will be 3, right? And for this one, there's no solution. Whatever value of x that I place there in place of x, it will never produce a negative answer, right? So meaning for this one here, there's actually no solution, right? You can try it out. You can place any value of x that you wish. You can place a negative 1,000,000. It approaches 0, but it will never go below 0, right? But it will approach 0, right? It will approach 0, but it will never even reach 0, right? Okay. But on a calculator, of course, a calculator is it is not that it doesn't have a huge display. So the big number that I place there, it will automatically give me 0, right? Because it doesn't have a big display. But if you use maybe a laptop or something, a device that has a big display, then you will get your answer right 0.00000 something, right? But for this solution, for this answer here, there's no solution. Then your final answer is actually x equal to 3. Okay, so I hope that makes sense. And yeah, let's move on to 1.1.5. 1.1.5. Let's move on to 1.1.5. Question 1.1.5. Here we're dealing with a third equation, right? So I have square root negative 2x plus 4 and then minus x equal to 2, right? So what's the best option here, right? So most of you, or most people, will multiply, will do this here, right? But you don't notice that when you do this, you will still have a square root, because when you do this, you will actually say this one square, well, this one raised to the power 2, it will cancel the square root, but then eventually you will have to multiply these two, and when you multiply these two, the square root will not disappear. And our goal here is to actually remove the square root, right? So what I'll do is I'll actually transpose the x to the left and to the right hand side. If I have x plus 2, so now I can square both sides, right? So I notice that the square root and the 2 will cross cancel if I have negative 2x and then plus 4, and then on this side, just solve this one, we have x squared and then plus 4x and then plus 4, right? And then you can solve this one. This is a quadratic equation. You have to put it in standard form. If we have x squared and then you transpose this whole lot to the right hand side, which will equal to 0. So if I transpose to the right hand side, I'll have plus 6x, and then these two will cross cancel, which will this will be the remaining part here, because you notice that these two will actually cross cancel. Okay, so then this one here. And then again, another mistake that people will do is to actually divide everything by x, which is wrong, right? So you have to, whenever you have a quadratic equation, you have to factorize first, right? That's where you get your marks, by actually factorizing. And then now I can actually say x is equal to 0, or x is actually equal to negative 6. And then whenever you have a third equation, make sure that you always test out your values of x, because in most cases, or sometimes, one of your x values will not satisfy the equation. Okay, so if I place x into this equation, it should produce a 2. So if I place x here, or 0 here, this will be 0, this one will be 0, and then I'll be left the square root of 4. Square root of 4 is actually 2, so meaning this y will satisfy the equation. And if I look at this one here, if I place a 6 here, I would have a 12, a positive 12. Positive 12 plus 4, that is 16, isn't it? Let me see, yeah, that is positive 16, and then the square root of 16 will give me 4, right? And then if I say 4 times negative 6, that actually gives me 10. So 10 does not give us a 2. So it means that this here does not satisfy the equation. And actually, test I did the whole math with my brain, so let me see, minus 6, yes, actually get 10. So we still don't satisfy the equation, so the only answer that, only x value that will satisfy the equation is x equal to, that's not equal to 6, that's definitely equal to 0. Yep, there you go, so x is equal to 0 in this case, right? So make sure, whenever you're dealing with question 1, make sure that you always test your answers, before you actually move to the next question. Yeah. Okay, so now let's move on to 1.2. 1.2 is a simultaneous equation. Okay, so we're given 2x plus y is equal to 3, and y squared plus xy is equal to 2. Is equal to 2. Okay, so here I can do two things, right? I can do two things. First of all, I can make y the subject of the formula for this formula here. I can make y the subject of the formula and then substitute my y into this point here. Or alternatively, I can actually multiply, no, if I multiply this with y, then it won't work. Okay, I can actually multiply this part here, hold on. Okay, so that's the first one. So here I can see that I have x, y. So if I can multiply this part here, I don't want to make this complicated for you guys, but then I can actually multiply this whole part here with y, so that I can actually have a y, and then I can actually multiply the whole part with this right here, right? So by doing that, what I will have is I will have 2xy. Let me just put this here. Okay, so I'll have 2xy and then multiplied by y half, and then plus I'll multiply everything by y half, so I'll have y multiplied by half y, which is equal to 3 use that color, then is equal to 3 multiplied by y half. Okay, so here we notice that the 2 and the 2 will cross cancel, and hence I'll have xy plus what, a half y squared, which is equal to what, 3 over 2 over y. So this is my first equation. Then my second equation will come from y squared plus, since I have this xy here, then is actually equal to 2, right? Then I can subtract the 2, these two will cross cancel. Then if I add these two, a half plus plus 1 will give me 3 over 2, so I have 3 over 2 y squared, which is equal to 3 over 2 y plus, or actually I subtracted, my bad, I subtracted so these two, so it will be a half minus 1, which will give me a negative half, right? So I have negative half y squared, which is equal to 3 over 2 y minus 2. Okay, so this is a quadratic equation, so I can have I can multiply everything by 2, therefore I'll have negative y squared equal to 3y minus 4. And then transpose the y squared over but this one is the more complex one, a more easier one. Remember, after solving for y, then you have to substitute your y value back into either of these formulas to solve for x, right? And then another method that I could use is to actually replace x, so that to actually replace x, right? So I could say 2x is equal to 3 minus y, and then can divide everything by 2, therefore x is actually equal to 3 over 2. The most yeah, I don't know, I don't want to solve. Okay, you know what, let me just solve. Let me make y the substitute formula, because that one seems more easier. So I have y equal to that, so I'm going to take this y and substitute it back there, right? So I'll have 3 minus 2x squared plus x times 3 minus 2x, which is equal to 2, right? So here we have 9 minus this times this is 6. 6 times 2 is 12x plus 4x, and then plus 3x minus 2x squared is equal to 2. Okay, so in this case I have 2x squared, then I'll add all the items. This one will give me this will give me 7, and then 7, this will give me negative 5x. And if I transpose this one, I'll get negative 7 equal to 0. Okay, so I'll have 2x squared minus plus 5x, and then plus 7, which is equal to 0. Okay, let me just, oh yeah, my bad. I can see where I went wrong here. Actually, this is supposed to be 4x squared. Okay, so I will have 2x squared if I add these two to the items, and then I have these two, which will give me 7 plus 2, which is 9x, and then minus 7. right? Yeah, actually class 7, which is equal to 0. Okay, so can I solve for this one? Factorize? Yes, I can. So I have 2x, and then I have x, so I need a 7. So I have 7 here, and then 1, and then minus minus. Cancel me that x should be 7 over 2, or x should actually be 1. Okay, so now let's prove that this one is correct, right? So I'm going to take a negative 4, then substitute it back here, and see whether I can get one of these x values. Okay, so our equation was 2x plus y is equal to 3, right? Is equal to 3. Okay, so I'm going to substitute my negative 4 here. So if I substitute negative 4 there, I have 2x equal to, or minus 4 is equal to 3. Therefore 2x is equal to if you add, since this one is a negative, not bad, remember we have negative 4 there, then if you transpose it on this side we have 7, and if you divide by 2, then you have x is equal to 7 over 2, right, which corresponds to this x value right there. Then you can actually solve for this y here. It should also correspond to this x value here. So, but let's prove that. So I have 2x, my y is 1, so plus 1 is equal to 3. If I have 2x is equal to 2, therefore x is equal to 1. Okay, so I hope it makes sense. So you can use either formula that is more easier. Excuse me. Yeah, you can use either formula that is easier, right? Okay, so now let's move on to 1.3. Let's move on to 1.3. Okay, so 1.3, they're saying consider the product, right? So remember, I've always made emphasis to these words that they will always come out, right? These words like integers, product, products, what's the other one? Divisions, yeah, all these types of words like divisions, different types of numbers like your real numbers, your integers. You'd say they will come out, they will pop out yeah, one of these days, and actually it actually popped up here, right? They're saying consider the product. So when they're saying product, they're actually saying multiplication, right? So when we're talking about a product, we're talking about multiplication or multiplying, right? So product, multiplication, and then division is what is division again? Okay, so but if you watch back my prior videos, then you will know these types of these type of words, right? Products, I've always made emphasis on these things here, right? They are very important, as well as an integer, right? So an integer is basically a number from it's actually a whole number that includes negatives, I believe so. Yeah, so a integer, so you can have negative integers and as well as positive integers, but in this case they say integer or integer, so it didn't specify whether positive or negative, so that means we're including every value, right? Every whole number value. Okay, so here they're saying consider the product 1 is 1 plus a half, 1 plus 1 over 3, 1 plus 1 over 4. Then this is a continuous of course, this is continuous, right? So each factor in the product is in the form 1 plus 1 divided by n, where n is greater or equal to 2. Okay, yeah, of course n starts at 2. You can see that n actually starts at 2, and it goes on to be 3, 4, 5, 6, and so on, right? So determine the values of n for which the product will be an integer value. Okay, so what they're actually saying here, they're saying you need to find the value of n, right? The values of n for which the values of n for which the product will be an integer, right? It will be a whole number, right? Okay, right? That's okay. Okay, okay, okay. So first of all, let's find our last value, right? Of course, our last value, I'll multiply, right? So I have 1 plus 1 over 2 times 1 plus 1 over 3 times so on, and then our last value should be 1 over our last value, which we define it as n, as given there. So that's our last product there, right? It's 1 over n. Okay, so if you notice a pattern here, if you notice what is happening here, you will see that here, if I go to this side here, the 1 is constant for every product that I have. The 1 is constant, as well as this 1 here is always constant. But the thing that changes is the denominator then, right? It keeps on changing to 2, 3, 4, 5, and so on. But if you notice something, if you go backwards, you can see that we're actually subtracting from 3 to 2. We actually subtracted 3 minus 1 to actually get 2, right? So to actually go back from here, what we will do, we will subtract n minus 1. Okay, so let me just rewrite this. I'll have 1 plus a half, and then 1 plus 1 over 3, and then 1 plus 1 over 4, and then times, and so on. And then I will actually have 1 plus, so you can see from, if I jump from this point to this point, then I said 4 minus 2. So in this case I can say 1 minus n minus 2 times 1 plus 1 over n minus 1, and then times 1 over n, not 1 over n, excuse me, so this is 1 plus 1 over n. Okay, so now what should we do? Let's actually multiply all of these, but first of all let's add the brackets first, right? Let's first add the brackets and see if each individual, remember, in order for us to actually get a to actually get your what do you call it, your integer, the bracket here inside should be what? Should be a whole number, isn't it? So it should be a whole number. Well, not necessarily it should be a whole number, but then let's see what let's see the pattern here. So if I add this one here, the first product, then I will have, this is 1 or 2 over 2, so I will have okay, so this is 1, that's 2 plus that, this is 3 over 2 times the bottom here, yeah, this is 3 over 2, and then here I have 3 over 3, this is 4 over 3, and then this one here will be 4 over 5, and then automatically here you can see 2, 3, 4, so that means here I have 5, here I have 3, 4, 5, here I should have 6, and so on. And then times, if I multiply this one here, I will have n minus 2, wait, n minus 2, that's n minus 1, because n minus 2 times 1 plus 1, so I'll have negative 2 plus 1 on top, which is negative 1 divided by n minus 2, and then times n minus 1 all divided by, this is n, right, and then times that times this will be n divided by n plus 1, isn't it? n plus 1. No, this is 1 This is n plus 1, this is n, yeah. So you should get something like this here. Okay, so if you actually multiply, if you actually see the pattern here, you can see that whatever I have here at the bottom, I have on the prior top, right? Like here for this one, I have 4 over 3. The 3 that I have here was previously our numerator, and we know that if I have 2 times 3, let's say 2 divided by 3 times, let's say 1 over 2, we know that whenever we're multiplying and there's actually the numerator, one of the numerator and one of the denominator are the same, and we actually cross cancel them, right? We can actually cross cancel them. So here you can see a pattern that this one is the first one here, so meaning these two will actually cross cancel, this one will actually cross cancel with the one that's in the middle, this one will cross cancel this one. Here this one will cross cancel with whatever will be there, and then this one will cross cancel with this one, and what we will be left with is this one here, since there's nothing previous to this one, so meaning I'll be left with 2, and this one here, since I will have nothing on the right hand side, therefore I'll only have n plus 1, right? So whatever we'll do, whatever values that will come after, or the last value there will be, I will always, now listen to this, I will always have something that looks like this. So whatever value that will come after, even if our last value here was 1 plus 1 over 5, it will be in this form here. It will always be in this form. There will always be these 2 that will be left here, as well as the n plus 1 that will be left on top. Okay, so now you have to ask yourself, here I'm dividing, and I'm actually dividing by 2. What value that can be divided by 2 that will actually give me a whole number? Of course, I cannot say n divided by 2 that will give me a whole number. That is not possible, right? That can never happen, right? So I can see a pattern here, but then if I say 8 over 2, I'll actually get, I'm not saying these are equal, but if I say 8 over 2, I'll get a form. If I say 3 over 2, I won't get a whole number, but if I say 4 over 2, I'll get a whole number. So what are you noticing? Well, I'm noticing that a 2 can divide every even number, right? Every even number a 2 can actually divide. So that means that here on top I actually need a whole number, right? I actually need a whole number. So how do I actually get, what is the value of n that I will place here that will actually give me a whole number on top? Well, since I'm adding a 1, that means that, and my n is actually has to be greater than or equal to 2. That means that here if I say 2 plus 1, I actually get an odd number on top. If I say 3 plus 1, I actually get an even number on top. Okay, if I say 4 plus 1, then I get an odd number on top. If I say 5 plus 1, I actually get what? An even number on top. So you can see the ones that produces, you can see, so from here you can actually see the values that produce a even number on the numerator. They are what? They are odd numbers. Alright, so meaning 3, since our n is greater than or equal to 2, so you're gonna start at 3. So that means that n is actually greater or equal to what? Or equal to 3, because 3 will actually give me a what? A whole number 2, right? So meaning n is actually greater and equal to 3, but then this applies only for what? For odd numbers only. This only applies for odd numbers. You can see you're actually jumping 4 will give me 5/2, which will not give me an odd number, but 5 will give me an even number on top, right? So and then 6/2 will be 3, which is an even number, which is a integral, right? So my final answer will be that n should be greater than 3, but then they should only apply for odd numbers. This will only apply for odd numbers, right? Hope that makes sense. And yeah, on the next videos we'll be looking at some other questions, question 2 up until 12. And yeah, thank you for